All right, guys, welcome back to day 2 of chemistry. I know you're all super excited to be here today. So let's start. Let's just start talking about balancing equations. This is day 2. This is the material we left off on last week before school, before spring break. We didn't all completely master this topic just yet, and I think it's a good place to pick up is right where we left off. So let me find my PowerPoint. Oh, there it is. Boop. Okay. So here's our PowerPoint. Um, Okay, we're going to talk about balancing these chemical equations. So now when we talk about balancing chemical equations, first of all, we'll talk about what balancing means. Then we'll talk about what chemical equations are. So what balancing means, it means to follow the law of conservation of mass. Um, when when a reaction takes place, you don't just lose things, you don't just get rid of things, you don't just create brand new things, right? Everything comes from somewhere. So these two green circles are what I started with, and the reaction took place, and I ended up with two green circles, right? So I still have the circles. The problem is these things they recombined. Um, so I have two circles before the reaction. The left-hand side is always called before. That's what happens before. The arrow is always the reaction, and then after the reaction, right? Before the reaction, I have two green circles. After the reaction, I have two green circles. Before the reaction, oop, 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 oop. After. Before the reaction, I have one, two, three blue circles. After the reaction, I have one, two, three blue circles. And finally, before the reaction, I have one, two, three, four, five, six red circles. And I still have one, two, three, four, five, six red circles after the reaction took place. So everything is balanced because I still have the same number of everything that I started with. I didn't create anything new. I didn't get rid of anything new. Um, Everything came from somewhere. Now they did recombine, right? They heated up, they broke apart, and then they got shoved back together in different ways. But I still have everything I started with. So the way this is going to look to you, right? I'm going to give you word equations, and then you're going to use those word equations. So let's say I have solid sodium chloride, solid sodium. You write that as NaS. The chemical symbol with this little s right here, which stands for solid, combines with, that's a plus sign, chlorine gas, which is actually written as Cl2. The reason why the 2 is there is because it is one of our diatomic elements. If you remember, the way you memorize the diatomic elements is with the word Brinkelhoff. Brinkelhoff. These are our diatomic elements: bromine, iodine, oxygen, nitrogen, chlorine, hydrogen, oxygen, and fluorine. All of these, if you see them, they're never going to be by themselves. Like sodium right here is by itself, right? It's not one of our diatomic elements, but chlorine is a diatomic element, so it is never written by itself. To produce, so it's the solid sodium and the chlorine gas, they combine to produce or to make or to create. That's our reaction. They create sodium chloride, which is written as NaCl. Now, something you need to see, right, this is this dotted line. I always draw this dotted line when I'm balancing equations. It's just super useful. And what that does, what the dotted line does, it separates the left-hand side from the right-hand side. It separates your reactants, which is the stuff you put into a reaction, from your products, which is stuff you get out of a reaction. And then, as some of you may have noticed, this isn't balanced. I have two chlorines here on the left-hand side, and I have only one chlorine here on the right-hand side. So to balance it, what we do is we put things in front of the molecules called coefficients. These coefficients change how many of the molecule we have. So now I don't have just a sodium molecule, I have two sodium molecules. I don't have one chlorine gas molecule, I don't have, well, I do have one chlorine gas molecule because this didn't change, it's still a one. And here I don't have just one sodium chloride molecule, I have two sodium chloride molecules, right? What that does, it says, hey, 1 times 2, I have two chlorines on the left, and I have 2 times 1, I have two chlorines on the right. That's balanced. I have 2 times 1, 2 sodiums on the left, and I have 2 times 1, that's 2 sodiums on the right. So let's get into how I'm counting these and how we can make sure these balance. Something to keep in mind though, do you see how that 1 just disappeared? Watch, I'll show you again. See, just gone. These ones don't have to be written. In reality, right, there is a 1 here, there's a 1 here, there's a 1 here, and there's a 1 here. If there's ever an empty spot, it means 1. So if the subscript is not written, I have 1 of that molecule. If the coefficient is not written, I have 1 of that molecule. So just keep that in mind when we're counting these. So, chemical equations. Some vocabulary I need to cover first is the word coefficient. Coefficient is how many of that particle are present. And then the subscript. That's how many of the element within the particle are present. When we're balancing these equations, you change the coefficient. You do not change the subscript. Ever, ever, ever. Never change the subscript. Subscript, only change the coefficient. And then the next thing I want to talk about is this little snickerdoodle right here. The S represents solid and G represents gas. And then, as you can guess, the L represents liquid. Those are our 3 states of matter because that shows us what state of matter the substance is in, because they would react different ways based on their state of matter. And then there's a new one here called aqueous. Now we haven't really talked about aqueous yet, but I think you can guess what it is. Aqueous, or aqua, means water. So if something is aqueous, it is dissolved in water. So it's typically either a gas or a solid that's dissolved in water. I don't think a liquid dissolves in a liquid. They can mix together, but they don't dissolve together. Now, let's go over how to do these. I'm gonna first solve an example problem for you, and then I'll go over it step by step, and then I'll do a couple more example problems. So the first thing we want to do is draw a dotted line down the arrow. What that does, it separates my left-hand side from my right-hand side. There will always only be one arrow. So you draw your dotted line through that. Now on my left-hand side, I have chlorine, right? Or I have carbon. I have hydrogen. And I have oxygen. On the right-hand side, I also have carbon. Now, here's the first mistake people do. They actually write it in order. So some people would write hydrogen and then oxygen and then carbon. This is a mistake because you need to keep these across from each other. What that'll do is it'll help you understand that things are already balanced. You don't have to do any more work once it's balanced. So we're going to do it in the same order. We're going to rewrite carbon, and we're going to make sure it's still there. Yes, we have carbon. We're going to rewrite hydrogen. And notice, yeah, hydrogen's right here on this side. And then we're going to write oxygen. The oxygen goes here. I know that's going to annoy some of you. Let me fix that O right there. Oh, that's an eraser. And then we have oxygen. And yes, we do have oxygen. Not only in one spot, but actually in 2 different spots we have oxygen. Let me get rid of my picture. You don't really need me anymore. Oop, 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 oops. Undo, clicker, get rid of my picture. I did that because I really need to scratch my nose. I didn't want you guys to see it. Okay, so carbon. Let's count how many carbons we have. Remember, if there's ever something not written, the coefficient is 1, right? The coefficient here is 1. The coefficient here is 1. The coefficient here is 1. When we're balancing equations, typically you're just going to start with 1 of everything and see if it's already balanced. Now I have a 3, an 8, a 2, a 2. There's nothing written for this subscript, so it's a 1. There's nothing written for this subscript, so it's a 1. And there's a 2 right here. Sorry, I have corona. Okay. So how many carbons do I have on the left? I have 1 times 3. I have 3 carbons. How many hydrogens do I have? I have 1 times 8. That's 8 hydrogens. And then how many oxygens do I have? I have 1 times 2. That is 2 oxygens. Now on the right-hand side, let's count. I have 1 times 1. That's 1 carbon. I have 1 times 2. That is 2 oxygen. And I have another oxygen here. That's 1 times 1, which is 1. So I not only have 2 oxygens here, but I also have 1 here. So 2 plus 1. That would be a total of 3 oxygens. Now let's count hydrogen. I have 1 times 2. I have 2 hydrogens. I wonder if I made a mistake there, if I said something out of order. If not, if I said something out of order, I'm sorry. Okay, now I've counted everything. And what's not balanced? Well, absolutely nothing's balanced. So we have to decide what to do. And typically hydrogen and oxygen here, you're going to balance those last. So let's start with carbon. I'm going to change this coefficient. Notice I'm not saying I'm going to add more carbons, right? We don't want to talk about adding carbons or subtracting carbons. What we want to talk about is about changing the coefficient. We're going to change that coefficient from a 1 to a 2. If I put a 2 here, I have 2 times 1 carbons. That's not balanced because I have 3 on the left. I need 3 on the right. So instead of changing it to a 2, I should change it to a 3. So now I have 3 times 1. I have 3 carbons on the right. And now carbon is balanced. Now something you need to remember is that this right here tells me how many of this whole compound or molecule or substance, how many of that I have. So yes, I have more carbons, but I also have more oxygens. So you do 3 times 2. Now I have 6 oxygens in this molecule, and I still only have 1 oxygen here. So 3 times 2 plus 1 times 1, that is 7. I have 7 total oxygens. Carbon's balanced, hydrogen's not balanced, oxygen's not balanced. Now oxygen is in 2 different spots. I'm going to save that for last. Let's balance hydrogen first because it looks the easiest to balance right now. In order to balance hydrogen, I have less hydrogens here on the right-hand side. So I want to make sure I change this coefficient to increase my number of hydrogens. And I want to try and get 8 hydrogens. So I know if I put a 4 here, 4 times 2 will be 8 hydrogens. The reason why I wanted 8 hydrogens is I know I have 8 on the left. So if I give myself 8 hydrogens on the right, that'll balance, right? The unfortunate part, though, is that it'll also change my number of oxygens. So now I have 4 times 1 plus 3 times 2. So I have 4 plus 6 oxygens. That's a total of 10, right? And the good thing, I found that now that I did that, now I have an even number of oxygens on the right-hand side. If I have an even number, I know I can balance this left-hand side because this oxygen goes up by 2s, 2, 4, 6, 8, 10, right? So I need to change this from a 1 to a 5. If I have 5 oxygens here, 5 times 2 is 10, so now I have 10 oxygens. That changed no other molecule, and now I have 3, 8, and 10. Everything is balanced.